Everyone, I'm Giovanni-Bortolin, and thanks to the fantastic collaboration with Nicola, Moretti, Karim, Farghaly, and Weiwei, Chen from the Bartlett School of Sustainable Construction at UCL. I'm going to present our research, that is an approach to the estimation of digital twins technological components. Just a little bit about my background. I'm working at quantity surveying consultancy, so I'm estimating and cost planning in the design phase and in pre-construction phase, all the way even for cost reporting in the construction phase until the completion. So, as we all know, the digitalization in the construction sector have many benefits. And some of them are, for example, the carbon reduction, the labor shortage and competitiveness, and the research and energy efficiency. So as we delve deeper into the digital twins concept and digitalization, well, there is the definition of digital twins. Well, we have quite a lot of digital twins researches here, and this is what we used as our definition for the digital twins. Also for digital twins, it is difficult, quite difficult, I would say, to drive the digital transformations, as we have only a couple of custom application, and as it is a concept also. So, what is the digital transformation cost? In the ACO, architecture, construction, engineering, operation, the costs do not only amount at the simple set of new technologies, but will also amount to the change management, the training and the workforce and upskill, the security, and the hardware and software costs. So, in construction, as what is mainly a project-based environment, and digital innovation will be realized through projects. And the project success is driven by the careful estimation of the main pillars: time, cost, and quality. In the pre-construction phase also, it is critical to estimate the cost to realize the client's requirement and the objectives, especially, and as we don't have the right budget, then we cannot realize, for example, the right quality and not in the right timeline, and the complication will arise. So currently in the industry, we use, at least in UK, we use bill of quantities as current standard for estimation, which can be used for pre-tender estimates, for example, or for going out to tender to the contractors. Obviously not price without rates. To develop it, we're using standard for estimation, as all stakeholders will understand what we are exactly estimating and what will be included in the type of measure and the description. So the research aim in this case will be to propose a method of estimation of technology components of digital twins through existing DT implementation, so through different case studies in our case. And it will give also a trampoline for the cost associated with the digital transformation in the ACO. So the current methods we use is the design research methodology. We went through to analyze the theoretical framework. We found different researches with case studies, and we analyzed them. We identify existing standards, so in this case will be the ISO standard for digital twin, actually in the manufacturing industry, so the 23247. And we designed a method of estimation for digital twins. So the tool we used, and this one is referred to the UK construction industry, is the new rules of measurement from the Royal Institution of Chartered Surveyor. We currently use for estimation and cost planning NRM1, NRM2, and NRM3. In this case, these are used also for the cost estimation and cost planning throughout the life cycle of a building, and also for NRM3, for example, for building maintenance work. So in our case, for this research, we took NRM2, which is for detailed measurement of building works, to produce bill of quantities, which could perform part also of the contract documentation and will constitute part of the contract. So to take the current cost associated with DT, as I say, we analyze the ISO 23247, even if it's for the manufacturing industry. And it provides us guidance for the DT system reference architecture. And we understand the capabilities for the digital twin system through the research and the case studies. So there will be, for example, a data acquisition with sensor and IoT systems, the data modeling, which will need data formats such as IFC and JSON, which allow for interoperability purpose, for example. Then we went through data analytics, which will give insights and prediction of the data provided, such as decision trees and artificial neural networks. Then we saw the actuation for digital twin, which, for example, will be the control of the heating, ventilation, and air conditioning, the HVAC systems. And also, for example, it could be towards fault detection. Not all research had actuation for digital twins, but, for example, the one that I identify are in these cases, for example. Then the last one is the curation, which is with data storage and maintenance of the data storage, and security system for the data, as digital twins system capture quite a lot of data, and this could be, for example, very sensitive. So this one is the current method of estimation that we developed, and is also an extension of the Neuroso Measurement 2, the NRM2 from their RCS. We use it as a basis. So we identify the different components, and we split it into sub-components to understand what we need to estimate for the cost of digital twin system technological components. And then, for example, this can be costed as itemized or enumerated, and it can be a fixed charge or a time-related charge. So we have, for example, the data acquisition. Then we have the data engineering, which is basically data modeling and curation together to simplify it. And then we have the data analytics and actuation. Also, on the excluded items, these are excluded items that we have already in NRM2, as it's important to exclude some item for estimation, which will not interlap, for example, with BMS systems, or are things that are already estimated through NRM2. So for a quick validation of this design method estimation, we use the interview process with some industry experts. We found a couple of benefits through the interviews. So, for example, this will allow to increase the transparency of the DT design and development process, and then it will understand what to quantify and what should be quantified in the DT system for its implementation. And it will be also in the agenda for the program and price from the beginning, and it will allow to basically understand what it is included in the DT system and what is the cost of it and of each component. So it will allow as well for some value engineering, for example. Some points of improvement for the design method, so the table before, is to expand the subcomponents, so it's quite simplistic. Each subcomponent, so it could be further expanded to understand better, maybe if we have more to expand towards it. And then identify some parameters to be measured, and to pay attention on other section which could interlap and could be costed twice, which we don't want it to happen. So as conclusion, we understood how digital technologies could be costed, which will allow with the budget and tendering, and will allow as well to the contractor to understand what to price. And it will help also in the design of the DT system, as it can be done in the pre-construction phase and during the design phase. The client will understand the cost of the DT systems, and in case provide some value engineering instead of maybe like just completely avoiding using digital twins in case the cost is too high for the lump sum. Further developments, we would like to do a case study for the demonstration, evaluation, and communication for the methodology, as we didn't complete it completely. And the main one is life cycle costing, to understand better the financial and economic impact. So if someone is interested, please come and contact me. And thank you. You can find my contact details as well. Thank you very much.